Yeah, we are good to go now. So yeah, my teaching philosophy is that I will always like teach the principle, like giving you the material and know how the equations get together to make the problems. And I will try to refresh your basics with adding some knowledge to you, and also refresh your old basics on dynamics or physics, whatever you taught the dynamics before, like the particles that you taught in physics. And my tip here is to enjoy what you are doing. Like, don't feel bored solving problems. Just enjoy solving the problems. Enjoy the learning process. Enjoying adding new skills. This will make it more easier for you. So, and I totally appreciate the effort that you have done before to be in this class. I know that you got a lot of work ahead of you. But as you know, like I know that you taught statics before, and dynamics is a little bit difficult than statics, so it might need more work from you. But I believe just putting some effort and solving examples, follow with lecture, you will be fine. Yeah, you got this. So we will have a class every day in Zoom. So we'll be meeting on Zoom every day, and the class will be should be recorded. So I forget this one to start from verse, but if I forgot to start recording the class, just somebody remind me that I have to start recording. But we are good to go now. The class is in recording mode, and it should be live on my YouTube channel. And I suppose that the Echo 360 is on now. So if somebody check the Canvas page and go to the Echo 360 panel, so I think I have to turn on the mic so the sound, yeah, can get clear. So I'll put the mic here. Yeah, so the challenges for the dynamic class is that just like be organized and don't let the lectures pile up on you. Just like do lecture by lecture. We will have lecture every day, 5 times per week. So you will have to be organized, put yourself on a schedule, study lecture by lecture, and we will have like at least 3 homeworks per week. So, and the good news is each homework is like 2 problems. So it should be like, doesn't take more than an hour to solve the 2 problems. Sometimes it gets like 3. So my recommendation is just like when you get the class, like uh, revise the notes and then start solve the homework. If you are done with the homework and want to exercise more, you might like try some of the examples on Canvas. So I have like a lot of solved examples on Canvas. I will show it to you in a few minutes. And this is for the class. So we will have, like as I told you, 3 homeworks per week. And the textbook that we will be using across the class will be a Hepler textbook. Feel free to use any version. So you can use the Hepler 10th edition, 11th. I will be using 14th. So 14th, if you were able to get it, I think it has a copyright, so you will have to buy it. And I'm pretty sure that there's like some used Hepler textbook. You might buy it, or and I think there is like free versions in online, so you might buy any of them. So yeah, so that's for the textbook. And so as I told you, like my tip is like to get through this class. You know that the summer class is a double speed, so it's like 8 weeks, not 16-week or 20-week like the fall and spring semester. You will have to be organized and don't let the lectures pile up. So you'll have to do lecture by lecture. And I totally recommend that you attend the Zoom live sessions, because Zoom live sessions, we will be having activities. You will have the privilege to ask me if you have any question or if there anything is unclear, so you can ask me. And you will follow up with lectures. Sometimes when you tell yourself like I'm going to watch the lecture later, and not watching it now or don't attend the live session. So it might mess up with your schedule. So it might like the lecture one by one, you might miss one and then miss two and then miss a homework and then miss a quiz and mess up with like the entire class. So I know that there are like, we only have here 15 participants. So I suppose like 10 of you will watch this lecture later. So I totally recommend that you attend the live session so we can have some interaction and you follow up with classes. Also, I will be using OneNote to write the lecture, like to explain everything and solve the problems. So you will have like uh, uh, whatever the learning strategy that you use over the years. I totally recommend that you have your notebook and your pen and write with me so you can keep follow with the materials that I'm explaining. And I think this is the best way. Like if you like keep watching, if this is your learning strategy and you are okay with it, so you are good to go. But I totally recommend that you write my notes with me, and then you have your notes in your notebook, so you might revise them later, or if you are okay with just watching, and you will watch the recording, and then you write the notes with the recording. So whatever is the best for you, do it. So how to succeed in this course as a group? So we need to work together. So help each other. I will help you and support you, and you might like you can like communicate with your peers, and if you have a question, and you can communicate with me, send me an email, or if you have a lot of questions, we might book a meeting and then go from there. So I will always be there for you, just like through the email, through the class, whatever it works for you. If you want to send me an email, and I also created a discussion panel on Canvas. If you have a question, just post your question on the discussion panel, and I will answer it whenever it's convenient. Yeah, I told you that we will need to work as a group, but we will be tested separately. So you are not supposed like to have the exams, the quizzes, or the midterm or final exams as a friends, like in the same room and helping each other. So this is not allowed, and there is a good conduct for this. So you are not supposed like to have the exams with any help of anybody in the class or outside the class. So you are not supposed to get any help during the exam. And you might like, if you want like watch any learning materials like online, if you want to watch any channel, follow the classes on these channels, or any online source, you are free to use any of these. And I'm going also to provide you some other resources, but not to distract you. My advice here, it's just like watching even attending the live session, the Zoom live session, or watching the recording first, and then solve the homework. And after you are done with this, my advice, if you have some time, you might check the Hepler textbook solved examples, and also you might check the other problems in Hepler textbook. So this is for the to keep you organized. If you have more time, you might check other resources. So there are a lot of resources online for the dynamics. So I just like want you to be focused and don't distract yourself with a lot of resources to watch. And this is my tip, like, and you will be fine. So let's now check the Canvas page. I'm going to share my screen. All right, so let's close this. So let's open the. All right, so Canvas page. Okay, you will go to the dashboard. You'll have to log in. And So this is our class, and I will go in the student viewer. So this is supposed the panels that will show up on your Canvas page, and you will have the Zoom link for the live session here in the dynamic YouTube playlist. And also, if you have any suggestions for the class, you might put it in this box. So also I have the links here for the echo, like the echo recording, and it's supposed like the recording should be on now. Oh, there's an error. So it's supposed like it be on, but we have a backup with the Zoom recording, and this will be the YouTube live session. So I'm pretty sure it's live on YouTube. Okay. And the announcement, I will like send an announcement almost every day for the checking with homeworks and telling you the deadlines. So this was my first announcement, the email that I sent to you a few days ago. So I will not communicate with email. So I will mostly do announcement. And just like keep your eye on the announcement every day, because I will be posting homeworks and learning exercise and with the deadlines, so you keep yourself on track and don't miss any of these. And here will be the assignments, so I will be posting the assignments here. So and I will have the deadline for each assignment. Mostly the deadlines for the assignments will be like Wednesday and Fridays. So if we will having like 3 homeworks, like some of them will be, the deadline will be on Wednesday, and some of them will be on Fridays. And this is the discussion panel that I told you before. If you have any question, like general questions, you might put it in this section, and then as they are divided by the chapters. So we have chapter 12, particle motion, up to chapter 19. Here's up to 16, but I might add the discussions for the other chapters, and your grades will be in this panel, and all the modules will be here. So they will be sorted by weeks, and each week will have the day of the, so we have Monday, I might forget Tuesday, but I will put it. And the recording will be here like on Monday, and if there's a class exercise, I will it will be here, and the homework will be in the same panel. Yeah, and if you want to communicate with any of your class peers, you might access the people, and you will find all the your class peers here in this panel. And if you want to check the syllabus and how the materials are organized, so you might check the syllabus panel. So you will have description about the class along with the prerequisite for this class, and about myself and how to communicate with me, and also the goals and learning outcomes from this class, logistics, the textbook that we will be using, and my recommendation to use the Hepler textbook 14th edition. And yeah, and here's the how to upload your homework. So your homework will be uploaded onto Canvas. So you will go to your homework, you will find it at if we go back, you will find a panel that has homework, and then you go to homework 1 and upload your homework sheet. It's better to use a white, not a lined or gridded paper. So you might like use the engineering papers, or the white A4 or A5 paper, whatever you are comfortable with. And yeah, so it's better to scan your homework. So it's better to have it scanned. I do not recommend taking pictures unless by your phone, unless they are clear and I can see them. If I couldn't see them, I will return the homework to you, and you will only have one time to send it back if it's still not clear. So I might reject the whole homework submission. So just like try to scan it, or try to have a clear version, so I can see the steps in your homework. And yeah, so here you'll find other informations, like try to check them to know the culture of the class, and for the assignments. So the total number of points of this class is divided into 10% on learning exercise. So I will be posting almost every day, or like 3 times per week, a learning exercise, one or two. And each learning exercise, it will accumulate in your learning exercise point. And then the total number of the learning exercise represent 10% of the class points. And the homework is 15% of the class point. And the homework will be graded on the effort that you put in the homework, like low effort, medium effort, and high effort. So low effort will be like you will get like 25% of the homework, 50% for the medium, and 100% for the high effort, not on the final answer. So it's basically on the how much effort you put in your homework. The quizzes is 25% of the total number of points for this class. So we will be having like 7 quizzes for the over the next 8 weeks. And for the exams, we will be having 2 exams. One is the midterm, which will be like after the in the Monday of the 4th week of this semester. This is the midterm, and the final exam will be on the Monday of the 8th week. So it's the final week. We will be having the exam on Monday. So this is how the classes and the exams. So I might like, yeah, I think the dates are accurate, except this one. I might change it to be August like 2 or 3. And here's it shows how's the grading look like 10, 15, 25 on the quizzes, and the other 50 is divided equally on the midterm and final exam. And here's how the grades look like for starting from A up to F. And here's the percentage corresponding to each grade. So you might check like the syllabus. So you, if you have any question, just like email me, or just like after I finish the introduction, you tell me whatever questions you have. And also we will having like 2 course survey, like one after the first week to check with you if anything that you want to modify to better having a better learning environment, if anything that I should do by my end. I'm talking so fast, talking so slow, need to solve more problems. So whatever suggestion that you have, I might like do a survey at the after the first week, and we will having, I think, another 1 or 2 surveys during this semester. It's supposed in the Eco 360, it's supposed like the the class is recorded class by class. So I don't know if it's recording now or not, but I might check later. But anyway, I having the class recorded on my computer now, and it's live now on YouTube. So we are good to go. Yeah. So here's the Hepler textbook. So I have the 14th edition. It has the first part is the statics, and the second part is dynamics. So the static is from chapter 1 up to 11, and dynamics from chapter 12 up to 22. And in this class, we will end our class at chapter 19. We will not going in deep into 3-dimensional kinematics or kinetics. So we will be having chapter 12, 13, 14, up to 19. And in the first week, our focus will be on chapter 12, which is the kinematics of particles. So let's open it for question. Does anybody have any question on anything that I told you, like syllabus, exams, quizzes, issues? So no questions? All right, so let's get started. Just like open the light. Just give me a second. So let's start some introduction, and it will be like a quick introduction. We have only like 30 minutes, so let's use it. All right. So I will be using OneNote during the class, and I will try to make my writing clear so you can see everything. So is like this type of fonts, like you can see it very well, or is it small? Just like somebody answer me if it's a small or I need to make it bigger. Anyone want to talk? Like tell me if this font size of my handwriting is good, like you can see it very well.
Yeah, it's pretty good.
It looks good to me as well.
Okay, sounds good. So let's get started here. So mechanics is a branch of the physical science that concerned about the states of rest and the state of motion of bodies subjected to actions or forces. And as you know from the static, the class that is prerequisite for the class, mechanics is divided into statics and dynamics. So the statics is concerned about equilibrium of bodies. So if you have like something like this, and is suspended by like two rope, and you have the weight like this, so this body is not supposed to move, and it should be like under equilibrium of F1, F2, F3. So this is the statics. And you talk a lot of things about statics, including moment of inertia or mass inertia or equilibrium of forces. You sometimes solve trusses like this. You have a truss like that, and it's on this support system. So this truss or this system is not supposed to move. It should be static. So we solve these forces on the truss, like if you have a force here, so all these forces should be in a static, is not moving body. But dynamics is concerned about the accelerated motion of bodies. So you have like a car or somebody like a pole or something is moving. It has velocity, it has acceleration. So it's concerned about moving bodies. Okay, so this is for the statics and dynamics. So let's get to dynamics, which our class today. So dynamics it is divided into two types of bodies. We will have particles, and we will have rigid bodies. And we will study for each one of these. We will study for particles, we will study what's called kinematics and kinetics. So kinematics is concerned about the position of the particle, the velocity of the particle, the acceleration of the particle. Kinetics is concerned about the force on the particles or the moment on the particle. And the chapters that we will be talking about the kinematics of particle is chapter 12. Chapter 12 in Hepler. So this textbook is the kinematics of particles. And the kinetics of particles, it will be chapter 13, 14, up to 15. And for the rigid bodies, it is the same thing. We will be talking about kinematics and kinetics. So for kinematics, it also the position of the rigid body, the velocity of the rigid body, and the acceleration. And here we will be concerned about the forces and moments. And the chapters, here is a chapter 16. And for the forces and moments, we'll be having them in a chapter 17, 18, up to 19. So the difference between particles and rigid bodies, so the particle is like we neglect how the shape or the like how the shape of the particle look like, or the body. Like if we have a car, so we represent the car with a point, like a particle like this, and we put the forces like that. So here's F1, and here's F2, and here's F3, something like this. And for rigid bodies, it's something like that. So we had to deal with shape and take the shape into account, and the forces might be here, and might be there, and might make moment like this. So this is how the rigid bodies, the difference between rigid bodies and particles. So let's have some historical backgrounds about. So for historical background, so one of the first guys that started to like do some experiment on using pendulums or falling bodies is Galileo Galilei, and in the 50s. So number one, Galileo in 5064. And then number two, which is the most important one, Isaac Newton in 6042. So Isaac Newton is the one that starts have some theories, and the culmination of his theories provided relationship between motion and forces. And he has, as all of you know, has three laws of motion. So we have law number one, and law number two, and law number three. So for law number one, it says like a particle remains at rest or continues in motion unless it acted upon by outside force. So it says like if I have this particle, it will remain at rest until you put some force on it. So if you put some force, it will make some motion. So, but if it's at rest, so the summation of forces on this particle equal to zero. Like if you like have two forces like this, so the summation of forces equal to zero. So unless it's on rest, so it's on rest, so the summation of forces is equal to zero. For the law number two, the acceleration of a particle is proportional to the resultant force. So it says that the summation of forces on the particle is proportional to the acceleration of this particle. And the proportionality factor is the mass, so ma. So this is the law that every one of you know, that the sum of forces equal to the mass multiplied by a. And this is represented by like if I have this particle and it's in motion, so it has some acceleration in this direction. So it should be like there are some forces acting on these particles, and the sum of them is not zero. So it has a sum of them is equal to ma. So you have force here, you have like friction, F of friction, and whatever forces that you have, the sum of all of these forces will be equal to the mass multiplied by the acceleration. The third law of motion is the force of action and reaction between interactive bodies. So if you have, let's assume that you have a wall, you have like a ring, a rod, and you have like a rod or a rod. This is a hook in the wall, and you have a rope, and you put some force on this rope like F. You pulled this rope from the wall. So the reaction here R, if you got the sum of forces, so F will be equal to R. So this is valid. So it's valid for interactive bodies. The forces are equal in magnitude, opposite in direction. So this is this is an x direction, this is negative x direction, and are collinear. So they are on the same line. So this is the three laws of motion that Newton's come across and have them, and we will be applying most of these principles in our dynamic class. So with this, let's move to chapter 12.2, which is talking about rectilinear motion. So for rectilinear motion, we means like bodies that are moving on a line. So like, for example, if this is a road and this is x-axis will be s, which is the position, and I have like, here's the origin, and my particle like is at this location. So if this particle is moving on this straight line and is not moving on a curve or in 3D, so we can call this motion as rectilinear motion, which is the one that we will be talking about in the chapter 12.2. So let's differentiate between some terms. So let's, number one, talk about position. So for position, we are meaning the location of the particle at any instant with respect to a certain origin. So you define this as an origin. So the location, the position of this particle is at 0. So s equal to 0. If the particle, and let's say this is time t equal 0. If the particle after 2 seconds is here, so and this is s, so this is what we call is the position. So the position is corresponding to a certain datum, which is 0 over here. This is for the position. So let's second talk about displacement. So displacement is the change in the particle position. So if the particle started at t0 and ended at t equal to 2 seconds, so let's put units here. So the final position minus the initial position will give you the displacement. So the displacement, we call it delta S, will be equal to S2 minus S1. And like, for example, if the particle at t equal, or let's say this is T1 or T node, and this is T1, and this is T2, and let's say this T2 is 3 seconds. So let's call this will be S1, and this will be S2. So if you are talking about the initial position will be at T1 and the final position will be at T2, so the delta S will be S2 minus S1. So it's the final minus the initial position. So this is for the displacement. And let's talk next about the traveled distance. So for the travel distance, we are talking about the total distance traveled by the particle. So for example, like if this particle goes like, let's make another one here. If the particle started at this location and go in the negative side and move back, so it goes here and then goes there. The final position of the particle is measured from here, like, so this is the position of the particle, if we are talking about position. And displacement, if the particle moved from here to here, so this is the total displacement, because this is the initial and this is the final position. But if we are talking about travel distance, you will have to account for this distance and this distance and this distance. So this is the total travel distance. So, and we call it ST. And let's talk about the scalar and the vector quantities. So the position is a vector quantity. So we need to know the position and is it positive or negative with respect to the origin. Like if it's in this direction, this is the S positive. So if the particle at this location here, so it will be negative. Similarly, the displacement, we want to know the change in the particle position, and also is this a change in the positive or in the negative. So it's still a vector quantity. For the travel distance, S total is a scalar quantity. So this is vector, and this is scalar. Because I don't care about whatever the direction of the motion, like is it in the positive or is it in the negative? So it should be like we calculating the total distance. So here's it cut a distance is moving in the negative, and did this distance like this, and then moving in the positive direction and made this distance, and then another positive one and gets here. So this is for the difference between displacement, travel distance, and position. And let's get to the velocity. So for the velocity, we have different terms to define velocity. So let's start with the first term, which is an instantaneous velocity. So the instantaneous velocity is the rate of a change of the particle position. So if I have the particle, like let's write this again here, and the particle at T1 here, and here's at T2, and this is S1, and this is S2. So the instant velocity is equal to, and it's a vector quantity, is ds vector dt. So this is, it gives you the instantaneous velocity at each display, at each like over the motion. So you can get it here, you can get it there. So you will have to differentiate the s vector, the position vector, and then you will get the velocity in function of time, and then you substitute with the time that you want. So here's at t equals 0, here's at t equal, like let's make this 2 seconds, and this will be 3 seconds. So if you want like 2.5 seconds, so you will get it from here. So this is an instantaneous velocity, means the velocity at any an instant, and it's a vector quantity. So let's vector. So the scalar quantity for the velocity, it's called Vs. It's the speed. So it doesn't matter if you are making the velocity in this direction or in this direction for the speed. So the speed, I just want to know your velocity is at 50 miles per hour, 20 miles per hour. I don't care about the direction. But for the instantaneous velocity, we care about direction. We need to know if you are going in positive or negative direction. So it's kind of similar, like Vs is like the scalar quantity of the velocity after excluding the sign, like positive or negative. So this is for the let's put something here, speed, and let's put it V S is equal to the P vector here. And number 3 is the average velocity. So for the average velocity, it's called V average, and it's a vector quantity, and it's equal to delta S over delta T. So it is not derivative. You will calculate the total cutted distance, like delta S here is equal to S2 minus S1, and you know the time delta T is equal to T2 minus T1, which is 3 minus 2 seconds, and you will substitute here. You will get the average velocity across the motion. So the velocity is changing, like the velocity is started, like for example, at this, let's say it's 2 meters per second, but when it gets here, it's like 5 meters per second. So you want the average, like 5 plus 2 over 2 gives you 3.5 meters per second. So this is the average velocity, and in instantaneous, it gives you the velocity at each instant. So here it gives you 2, here's gives you like 2.5, 3, 3.5, and so on. So this is for the average velocity. Let's get to number 4, the average speed. So the average speed, which we call it VS or VSP, average. The average speed is the distance traveled over the delta t. So for this example, you will calculate the total travel distance. You cut this distance and then came here and then this. So you will calculate the time from here to get there. And also you calculate all of these distance to get the average speed. So this is the difference between speed, velocity, average velocity, and instantaneous velocity. So to make this concept clear to you, let's assume that the origin is your home here. And you get to work at this location. So here's your work, home, work, and this like, let's make this home, sorry, this work. And here's where you do shopping. So first you went from home to work, and then after work, you got like from work to shopping, and then after shopping you get back to your home. So when you get back to your home, if you are talking about your position will be 0, because yeah, you cut all of this distance, but you return it back. So it's a 0. But if we are talking about total distance traveled, you will have to calculate this first distance that you cut, then the second, then the third. So you will have to account for all of these distances. And let's move to acceleration. So for acceleration, we have 2 terms. One of them is the instantaneous acceleration. So for instantaneous acceleration, A, it's a vector quantity. It equal to dv dt is the rate of a change of the velocity. So you will have to identify the rate of change of the velocity. So like, let's get to our example here. And here's 0, and here's the particle here. So we will have to identify the rate of change of the velocity, how to change it, like for example, it goes here v1, it goes here v2, and we need to know how's the velocity is it changing across this motion. This is the instantaneous acceleration, and let's get to number 2. It's the average acceleration. So the average acceleration is still a vector quantity. We call it A average, and it doesn't care how is the velocity is it changing here. It only cares about the starting velocity and the ending velocity, the initial and final. So it equal to v2 as a vector minus v1 as a vector over delta t. If the acceleration is positive, so if the rate of change of the velocity is positive, that means that the body is accelerating, means that the speed is increasing. If it's negative, that means that the body is decelerating, means that the speed is getting decreased. All right, so this is for now. So let's like have a very quick example on this. So let's say that we have, okay, so let's say that this is the S and this is the origin, and I have a particle that is described, the position of the particle is described over the time by 10 t squared minus 12 t, and t is in seconds. So now if you calculate at t equals 0, and we calculated S it will give you, let's say t is in second and s is in like meters. So if I put like 0 seconds here, it will give me that s will be equal to 0. But if I put t is equal to 2 seconds, it will give me 16 meter. So let's say that the particle here at t equals 0 and the particle here at t equal 2 seconds. So let's apply our principles. So we just calculated the position at t equal 2 seconds, and this position gives us 16 meter. So let's calculate the velocity, the instantaneous velocity of this particle. So if you want to calculate the instantaneous velocity of this particle, v, it's ds by dt, which will be 20 t minus 12. So this is the velocity. If you want to get the acceleration, so a will be dv dt. If you differentiate this equation with respect to t, it will give you 20. That means, and it's positive, that means the body is accelerating. However, you will have to be careful. Why? Let's draw this here. And our particle at t equals 0 is here. But at t equal 1, if you substitute here by 1, it will give you that the particle moved in the negative direction. If you substitute here by 1, it will give you -2. So you will get here -2, and then moved back at 2 seconds, moved back +2, and another +16. So this is how the motion look like. So if we are talking about displacement, not displacement, if we are talking about total distance traveled, so you will have to account for 2 + 2, 4 + 16 is 20. So this is the total distance traveled. And if you calculate the velocity at t equals 0, so if we get here, so here's the velocity at t equals 0, it will be -12 meter per second. So at t equals 0, so that means the body first has 12 meter per second in this direction. If you calculate it at t equal 1, if you put 1, it will be like 20 minus 12 will give you 8. That means the body here has, so this is -12 meter per second. And here's it will move in the other direction with 8 meter per second is positive. So this is how the velocity was changing over the motion time. So starting from 0 up to 1, ending up to at t equal t2. So you can right now calculate all of these things, the instantaneous, you will have the total time, and you will have the total distance traveled. And also you can calculate the average. So the average, the delta S from 0 up to 2, it will be only the 60 meter, because this is t at 0 and this is t at 2. So there's a difference between the delta S and the total distance traveled. So this is how it looks like. All right, so this is for now, and we will be solving more examples starting from next lecture. So I want to test these concepts in like 4 minutes class exercise. So how about if you go to Canvas and try to go to Canvas, all of you, and I will make a breakout groups, and we have like 13 right now, and I'm gonna divide you into like 2 or 3 groups, and we will go. You will go to the class exercise, and I will have 4 questions with you. I want you like to answer these questions, and we might discuss them like next time. But I was just like 4 questions. Each one will take like a minute. So just like we will do it very quick. I will put the link in the chat. Just to test. I don't know. Can anybody like check with me if he can see this exercise?
Yeah.
Were you able to access it? Okay.
Yep, I can see it on Canvas.
All right. So let's make breakout rooms. Okay, I'll create 2 rooms, just like give you 3 minutes to solve these questions.
Hello, Professor. Can you hear me?
Yeah.
So I just learned today, unfortunately, that I have another class that overlaps with your live lecture time.
Okay.
So I was wondering when your lectures were going to be posted to YouTube or Echo 360.
It's supposed like they are live now. So after we are done with the class, the recording will be there. If it's not, I will upload it in just like 2 hours from the class time.
Okay. Thank you very much.
Yeah, sure, no problem. So welcome back, everyone. So because of the time, we will be like, I will giving you some time to think about these 4 small problems, many problems, and we will be discussing each one of them next time. And our first homework, I will be assigning our first homework during tomorrow's lecture. And see you tomorrow.
Thank
Have
you,
a great
Professor.
day, everybody.
Thank you.
Thanks, you
Thank
too.
you.